Hi guys, in this tutorial, I'm gonna solve question number 5, paper 43, November 2021. Particle P moves in a straight line starting from rest at O. When it's written start from rest at O, means when T is equal to 0, V equals 0, and displacement is equal to 0. This is important point. Starting from rest at O. So he started to count the time from O. This means when T equals 0, displacement equals 0, and velocity is equal to 0. At time Ts after leaving O, the acceleration of the particle P is, acceleration is K times 16 minus T squared meter per second squared, where K is positive constant, and the displacement from O is S. The velocity of P is 8 when T is equal to 4. It's given another information. When T is equal to 4, velocity is equal to 8. This is the given information in the question. Show that S is equal to 2. How to get S from acceleration? You have to integrate twice. Integrate acceleration respective to time to get velocity, then integrate velocity to get the displacement. Let's start now to integrate. For integrate, A will be V. Integrate, K is constant. Integration of 16 will be 16T. Integration of T to the power of 2 will add 1 divided by the new power. Then plus C. The first information given when T equals 0, V equals 0. When T equals 0, V equals 0. V is 0 is equal to K, T0, T0 plus C. So now it's clear the value of C is 0. So now velocity is K, 16T minus third T to the power of 3. It's also given another information. You can use it to find the value of K, whereas T is equal to 4, V is equal to 8. V equals 8, K, 16 times 4 will be 64, minus third, 4 to the power of 3 will be 64. From this equation, you can find the value of K. It's 8 divided by 64 minus 64 divided by 3. So the value of K is 3/16. Now, the final answer for the velocity expression is 3/16 multiplied by 16T minus third T to the power of 3. Integrate again, find displacement. 3/16 is constant. 16 to integrate T, add 1 divided by new power, minus third when you integrate T power 4 divided by new power, then plus C. By the same way, when T equals 0, S equals 0, so you will get again C is equal to 0. So the final answer of displacement, S is equal 3/16. 16 divided by 2 is 8 to the power of 2 minus 1/12 T to the power of 4. But he asked you to show that 1/64 T squared, look at this bracket, you have to take T squared and 1/12. If you get 1/12 T squared, the first fraction 3/16, if you multiply it by 1/12, you have to get this value, which will be 1/64. Now it's correct, 1/64. And also if you take T squared outside, you will get, when you divide 8 by fraction 1/12, so the answer will be 96 minus T squared. This is part A. Part B, find the speed of P at the instant when it is returned to O. Return to O means S is equal to 0. By using the expression of displacement in part A equating with 0 and solve your equation, 1/64 T squared multiplied by 96 minus T squared is equal to 0. If we have two factors, their product is equal to 0. So the first factor is equal to 0, or the second factor is equal to 0. By solving the first equation, you will get T equals 0. This is at start of motion. And by solving this equation, you will get T is equal positive or negative square root of 96. But time have to be positive. So I will take only the positive value. You can keep it square root of 96, or you can write it for root 6. This is the time, but he asked to get the speed. You have now to substitute by this time in the expression of velocity, this part. V is equal to 3/16. 3/16, 16T, 16 multiplied by root of 96, 16T minus third square root of 96, all to the power of 3. Find the value, 3/16. 16 times root of 96 minus third multiplied by root of 96 all to the power of 3. The final answer V is negative 29.4. This negative showing that the particle changed direction of motion, but the value of velocity or speed, its magnitude will be 29.4 meters per second. Part C, find the maximum displacement of the particle from O. The maximum displacement of the particle from O when the particle starts to return. Particles start to return, this means V is equal to 0. When the particles start to return or start to change direction of motion, so we use V is equal to 0. Back to the expression of the velocity. If you take this expression equating with 0, 3/16, 16T minus 30T squared is equal to 0. By taking a T outside, 3/16T will be 16 minus third T. Sorry, it's T to the power of 3. It's T to the power of 3. When you take T outside, is equal to 0. So 16 minus third T squared is equal to 0. So 16 is equal to 30T squared. So T squared is equal to 48. By taking square root will be root of 48. So the maximum displacement happens when time is equal to root of 48. Now we'll calculate the value of the displacement. We can substitute of the expression which is given up, show that, or when he asks to get the value. If we substitute in this expression, 1/64, and the T is square root of 48 squared, then 96 minus root of 48 squared. Now we'll calculate this value. 1/64 times square root of 48 all to the power of 2, open bracket, 96 minus root of 48 close the bracket to the power of 2. So you will get the final answer 36. This is the maximum displacement when the particles start to return. So the final answer have to be 36. Thank you.